All right, so we're we're going to look at something. We're going to continue on algebra. Today we're going to look at adding, 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 and subtracting in algebra. All right, so head up for me.
At a substitute.
Sir, if you're talking, we're not hearing.
All right. Okay, so adding and subtracting in algebra. All right, guys. So one thing you need to understand is in algebra we have something that we call terms. All right, so all these
Variable.
no man, all of these are called algebraic terms. You see the numbers? They're called coefficient or constants. So the numbers, oh, I'm going to write this now. Oh boy, I'm in problems. One second.
Could I write one by one alone, and just write out the what they mean, and continue with the give with the example for the others or something.
All right, thank you for your input. All right, so the numbers are called what? Coefficient.
And
The letters, somebody said it a while ago, it starts with V. The letters are called what?
Variables.
Right, variables. Sometimes they're also referred to as terms. Oh, hold on, guys. This, let me write another name for this. Sorry about that. Just remember, this is actually called an algebraic expression. Algebraic expression. Sorry about that. So the 7ab, the 6x, the half, y squared, what are they called? Algebraic expressions. The numbers are called what? Coefficients. And the letters are called variables or terms.
So I think that coefficient, I think you should set it properly, because I just see something scribble up over the corner there and I try to figure out what it is.
All right, because of space, I have to move on to another slide. So tell me when you finish. All right, can I move on?
Snapchat camera.
Sir.
And go ahead, sir.
Sir.
Oh.
Sir, you mute me and me ask you a question.
Go ahead, miss.
But you move, you change your voice.
Yeah, but you're saying sir about 2 times and
But you not acknowledge me, sir, so how me go talk? It's alright, never mind, continue.
there you go, miss. Quickly write it off. Please tell me when you finish, yeah?
Yes, sir. I wanted
right.
to know if that X was not written properly. So I wanted to know what it was. So right on my see.
Which X?
The 6 in a circle and then that looks like an X.
It's an X, yes, an X. All right, okay. You get that, miss?
Yes, sir.
All right. All right, so you have some basic rules. All right, so rule number 1, we cannot add unlike terms or unlike variables. All right, so we cannot add them. In other words, for example, we can't say 3m plus 4n. All right, that won't work here because what? The variables are what?
Different.
And likewise, with subtraction, we cannot what?
Add them if the variables are different.
Well, we cannot subtract.
Subtract.
Unlike variables. So you can say 5x subtract 2k. All right. So the conclusion is that we can only what?
Only
And if the
this
variables are alike,
Right.
if I have 5x, take away 2x.
Right, very good. So we can only add Add or subtract. Like
Yeah.
or same variables. Hold on there. Example, as you just said, like for example, say 2x plus 3x is what? 5x.
5x.
Right. All right, so let me give you a minute or two to write.
Sarah,
No, man, I'm just waiting. You guys finished?
oh, okay. I thought you were talking.
All right. Can I move on?
Just another couple seconds, sir. 30 seconds
Alright.
tops.
Okay. It seems that I run out of slides. Oh. Okay.
Sir,
Go ahead. Yes.
when you have like the variable with the square at the end.
Mm-hmm.
When you have the variable like you have negative half on an with the y and the square at the end. What do you call that again?
It's still a variable.
Okay.
Yeah,
But
man.
it's only twice. You square the
For example, you could have something like this. Negative 2m squared y6. All of this is called a what? A variable. But in terms of working it out, we don't reach there as yet. All right. Okay, let's look at some examples. All right, guys, give me a few minutes. Let me try so we can bring up a textbook. Let me see if I can. I have this textbook. Alright guys, so unfortunately, this is so strange. There's a big textbook and there's nothing like this in it. Alright guys, sorry about that. But we're gonna use it. Alright, let us make up some examples. So the instruction would be to simplify. Alright, take a few minutes to write out those questions and leave a little space, alright, for the working note.
Sir,
Go ahead.
a negative 11m and what that? Negative 3x squared and the last one AB.
Hold on, you tell me the answers?
Yes.
Oh, that was fast. No, I don't work them out as it. No, I just made them up.
I mean number 2 at positive. At positive 3x squared. That? No?
You asked
No.
me. You asked me if this is positive.
No, sir. Sorry. A negative.
All right. I'm not sure what you're talking about. All right. So what you know about all these questions? Look at the variables. All of them are what? The same, true.
Same variable.
Right. That means that we can what? Add, and we can what?
Subtract.
Thank you very much. All right. Now you can do this out your head mentally, but as an instructor, this is what I would love for you to do. For those who want to do it step by step, what you do is you separate the variables from the numbers. So you have negative 7 plus 2 subtract 6 for number 1, and you write the m outside the bracket. You don't have to do that, is there? And then you just work out whatever you have in the bracket there. So, all right. So let's work the bracket. According to bottom. Okay, Miss, just give us a chance. According to BODMAS, what do we have to do first?
We have to add first.
Right. What is negative 7 plus 2?
-5.
Negative 5.
Negative 5.
Negative 5.
And you drop by -6. And what's -5, -6?
11.
Negative
Negative
Right.
1.
Negative 11.
Negative 11.
7.
So it'd be negative 11 and we're by the M. Is that?
So I did it the other way, but I
No,
did
sir,
it.
no.
Which other way did you do it?
I did it the other way. What I did was I said negative m plus 2 give you 5m, and then I put the takeaway sign and put 6m. But I didn't know that I should add the 6 and the 5 and I get 11, but I take away and I get negative 1m.
That's the wrong one.
It's a different way, no, sir.
That's a completely different way. That's a
Yeah.
completely different way. Because what we always say to you, add before you add. You subtract, too.
Yes.
Right. Okay, I heard somebody in the background say they don't. What is it you don't understand? All right. Nobody's...
Sir, hear my way.
Hold on. Somebody said that they don't understand. Hold on. Is there anybody in class who not following? If so, please tell me what part you don't get.
Question, sir. Which rule do we follow with regard to working out the brackets?
All right.
Is it the multiplication rule or the addition rule?
All right. Question: do you see any multiplication sign anywhere at all in those questions?
No.
No. So you can't use a multiplication. So you
There's
use
the addition rule.
Right. All right. So you use the rules of addition and subtraction, but sometimes you have some questions where it starts off with multiplication, and then when you work out the multiplication, you're left with what? Adding and what? Subtracting. All right. Yes, boss. Go ahead.
All right, sir. Read away, yeah.
Me know the way, no, but
yeah, I know. Negative 7m minus 6m.
Okay.
So yeah, I get 13. So plus the positive 2.
Right.
Yes, because you have 13 thing and then you pair 2 or die.
Yeah, man. It can work, so but what you do is you just shuffle up the number to please yourself. All right, which is perfectly fine. All right. All right. So I want you guys to try question number 2.
Negative 3x squared.
All right. Needed upon the ball. Anybody need time? Everybody finished already, or me I go too slow?
Sir, you should write it off.
Negative 83.
All right. Let me give you 2 minutes to work on number 2 and number 3. Go ahead.
Yes. Yes. I'm doing number 3. No. 3AB negative.
You might mute, yeah?
All right, who wants to take the board? Who wants to write? Who wants to become maths teacher?
3 plus 4 is 7.
Oh, no man, hold. I need somebody who's able to write on their screen. Can you do that? Can you do that?
Alright, let me see if we can. I this.
Yes.
Wait there.
What erase that?
I erase that now.
Look for the eraser. Tell me when you're ready here.
Alright, sir.
All right, go ahead. You have the floor.
Alright, so 3. And I keep the mirror. Right? But then too big. So you said 3 plus 7. 3 plus 4 equals 7. Right? And you keep the x square. And then you go minus the. You go have the negative 10 with it. So me can write small, you know.
Continue, you're doing perfect. You're doing perfect.
Alright. Let me try write the code. So 3x square plus 4 x square minus the negative 10 x square. So yeah, this is the answer. You get 7. Yeah, 3 plus 4 equals 7. And you have x square, and then you go minus 10. Have the minus 10 with it.
Yeah, man, you're doing beautiful. Continue.
And wait there.
And your answer going to be negative 3 square.
Yeah. 7 from 10, you can't get
we'll make the girl get her glory.
I'm sorry, I apologize.
No man, you're still her glory, man.
I apologize, I'm sorry.
She was doing extremely well in terms of explanation.
And number 3 is 0.
All right.
Number 3 is AB.
All right, thank you very much, Miss. That was beautifully explained. I need somebody to work on number 3. By the way, any questions for number 2?
Sir, I didn't get the answer for number.
For number 2, all you have to do.
Negative 3 square.
You have to add first, don't you? Right? So let's separate it. Let's separate the numbers from the variables. So I'm separating the numbers from the variables. You have to add first, right? 3 plus 4 is what? 7. 10 from 7 is what? -3, and I write back the x squared. All right, so notice I don't do anything with the variable. You just write it back.
Variable term.
Right. All right, who wants to go ahead and work out, who wants to write, write on the board? Let me
That's
get some.
not right. Can you write for the person?
Oh man, I want somebody can write, man. No. Roger, do some writing sometime, you know.
Yes, sir. Me do it.
Yeah, do it. Yeah, man, cause
Yeah, man, me do it right. Okay, so for number 3, you're going to say -7ab plus 10ab equals 3. Wait, let me get a pen out.
Yeah, man.
3. Hold on. Trying to get my pen out. Hold on, guys. I'm trying to get out a pin from this. It's not okay. Here we go. So I'm gonna say -3 -3ab, right? So we work out, we add first based on BODMAS, right? Then after that we get -3ab minus -3ab, right? Which is going to give us.
Hold on, Roger.
Negative.
Okay.
Negative.
Hold on.
Negative.
Hold on. How you get
-7? Okay, -7 minus 10.
Yeah,
Right?
yeah. What is that? Talk about Mr. Brown shop.
Okay, so for Mr. Brown shop, right? You owe him 7ab. We went and pay 10ab. Leave us with 3ab.
So I got half. So it's going to be a plus.
So yes, sorry about that.
Yeah.
Yeah, that should be a positive. Sorry. So let's just change that to a positive. Which, let me just erase that. Okay,
Make it cross.
Okay. Right. So we have 3ab minus 3ab, which gives us 0. It's just 0. No variables and no constants.
All right, very good.
Sir, can Roger go over that back, or you please?
Sir, please go back. Yeah, can you go back around that?
All right, thank you very much, Roger. All right, basically you're gonna separate what? The letters from the what? The numbers, are true?
Sir, the negative 3ab minus 7ab.
I got that 7ab, sir. It was negative
It both ways.
by 7ab. That's why I was confused. I was like, where's the other 3?
Because I had 7ab.
All
yeah,
right.
I was wondering where did the other 3 come from?
Yeah, it's a mistake, man. It's a mistake. It's
I
probably
was
the KFC in front of me is distracting me. So, all right, just kidding. All right, so you have to add first, don't you? No, so you go. So you're at negative 3. As Roger was saying, your ohms are around $7. Go shop with $10. Pay off your debt. You're gonna have some change, right? How much change you're gonna have?
3.
Right, $3. So this is just 0. AB, which is what? 0.
So which is just AB then, typically.
So how is something? Oh, okay.
In that,
AB and
would it just
variable
put
term.
AB or you just put 0?
It couldn't be AB. The only way it could
Maybe I
be
mix
AB,
up.
the only way it could have AB there for the answer if the constant is 1.
Okay.
Because 1 times AB will give back AB, but 0 times AB will give you 0.
0.
And you know, funny enough, you might do this question and get this part, and then you write AB, and that will be incorrect. All right.
Sir, so 0 you must write alone?
Yes. Yeah.
Huh?
Yes.
Okay.
Yeah. Don't put anything else here except 0. All right. Let's move on with some more questions.
So can you erase number 3 so the word don't jumble up, please?
All right. Please take extra care to write up these questions.
Hey, symbol them go have to change it, the plus and stuff.
I'm not following you.
Sir, I
Like
can
when you
just have,
move over the sign them.
All right. Tell you what. Just write out the question and explain what to do here.
sir, I wanted to ask you a question.
Go ahead.
Can go ahead? All right, so like how you have 7m or 4m, 7m, you could just add
Hold
the 4 and
No,
the 7,
it's for MN.
4mn and 7mn. You
No,
could
it's
just
it's minus 7mn. You see,
So,
all right, let me tell you. You see the sign that is in front of the term? you have to mention it
Okay.
here. The sign that is in front of it, you have to mention it
Can
also.
read it.
All right, okay, guys. In a nutshell, we're gonna group what? Like terms.
Like
Right. You can do that. And then what happened is that if you're gonna move the 7m beside the 4mn, whatever sign is in front of the 7mn, you have to move it to here. Also, if you notice, the second term is AB. Can someone tell me what number is actually beside AB? There's a 1.
AB, sir?
There's actually a 1 beside it here. This AB here, you can't
Yeah,
see
it's a 1.
you don't see the number, but there's actually a 1 there. All right. So write up the question and I'll explain what to do, right?
So it's number 6, 10A or 100 squared.
No, it's A.
Okay.
Sir, is number 6 minus 10 A square B?
Yes.
Okay.
Okay, I trust that you have the questions now. Oh, hold on. What sign was actually here? Number 4.
Minus.
The plus?
Minus.
A minus. Okay. All right. So as I said before, guys, we're gonna group like terms, right? Oh boy, so I don't have any space. So
Erase.
let me just make it. No, we can't. If I erase that, will cause problem. All right, so you're gonna have 4 mn subtract 7 mn. But remember now, is this subtraction sign here? It is from here. Then we're gonna have minus AB. You can put a 1 there for argument's sake. Plus 6AB. Everybody see that?
Yes, sir.
Then you just work this thing out. So 7 mangoes from 4 mangoes, I'll give you
-3.
right,
mm.
-3 mn. And this is 1, right?
Okay.
So your ohms are brown what? $1. Go shop with $6. You're gonna have change by sweetie. How much change I gonna have? 5. And that's your answer. Because as you can see, mn and ab are what? Unlike terms or variables. So you can't add it. So this would have been your final answer. Any questions?
Yes, sir.
Go ahead.
Why did you keep the plus sign?
For what? Beside the 5?
Yes, sir.
No, I didn't keep it, I actually worked it out. Because, no. you owe. No, it might appear that I'm keeping it, but I'm not keeping it. I'm actually working out what all of this can give you. So you owe $1, you go shop with $6, you go half. Half means what?
Oh, see, I talk about Mr. Brown now. All right.
Yeah. So I want you guys to try 5 and 6. I'm gonna give you 4 minutes to do that.
Four minutes to do what, sir? Sir?
5 and 6.
Sir, number 5 a level x squared.
Yeah, move so speedy.
Sir, level x squared number 5. Hello?
Your answer is not complete, but you're partially right.
Because the negative 3y squared plus the plus positive 3y squared will give 0. Because you owe.
But what about the -1?
See it, thanks.
I'm done tomorrow. Don't pull out 9.
What?
Negative I mean 6 negative 11 a square b plus 10 ab square minus a square b square the number 6 because you group them like negative 10 a square b minus 1 and then a plus 7ab square plus 3ab square
All right, guys.
a square
So I stepped
and
away
b.
a while ago. So all right. Any All right. So please mute your mic, please. Somebody's mic is open. All right. Okay. Any takers for? Just raise your hand for me. Any takers for question number 5? Okay, Miss Williams. Go ahead.
So what I did for number 5 is I put back 5x squared plus 6x squared. And then I wasn't so sure about the negative 1, so I went ahead to put 3y squared, take away 3y squared negative 1 plus negative 3y squared. Not sure if that is correct. Then I went on.
Why wouldn't you just put this 3y together? Because you're grouping them, not true?
Yes.
Yeah, that's what you should have done.
Oh.
So you're putting the like terms together.
Right.
Well, you rightly said that you didn't know what to do exactly because it's unlike. So, but you still can't get rid of it. I mean, it's there. All right.
Okay.
Okay. So continue from there.
Okay. So after that, you would say 5 plus 6 would be 11 square.
11x squared.
11x squared, sorry. And then 3y squared negative 3 squared, that would be negative 1 square? 1y square?
No man, 0.
0? Oh.
Yeah. So what left back is just what? Negative 1. So that's the answer.
I had a negative 1y square. I don't know.
3. What's 3 from 3?
0.
Exactly. So 3y squared from 3y squared will give you 0.
Okay.
The only way you can get 1 is say, unless you're going to say 3y squared from 4y squared. All right. Any questions, guys?
Sorry.
Yes, go ahead.
Yeah, may I say, right down the surface part, where you cancel out the 3y them.
Right.
You could just actually put back a y. Y equal 1. Sorry about that.
Y equal 1.
Yeah, we gotta speak out it.
Y equal 1 E. So
voila.
So x equal to 2. No, y is not equal to 1.
Y on its own
Y.
is a 1.
No, you wouldn't say. You'd say y. You'd say 1. You'd say y can be written as 1y. You can say x can be written as what? 1x.
1x.
Okay, so the y would actually work back. You can just put a 0.
Yeah, man. No, if you put back the y, you go wrong.
Yeah.
Because you basically said.
So you can't put y squared, sir.
No.
No.
Let me tell you what you can put back. You can put back 0y squared. This is the 3y square. It's the 3y square minus 3y square. You can do that. But 0y square is what? 0.
Aye.
Any questions?
So sorry, the y doesn't have any value.
No, it doesn't have any value.
The value of the y is 3. But if you're gonna minus 3y squared from 3y squared, it's basically saying y squared minus y squared is 0. It's just
Okay.
The letters don't have a value here. We're not doing substitution. All right. We're not doing substitution. In substitution, they tell you what the values of the variables are. Remember? So
Okay.
yeah, man. In substitution, they tell you what they mean. You notice our answers end up with the letters. The answers we get don't end up with a value. It will end up with a what? A letter. That's why the instruction would say what?
The letters, the value.
Right. The instruction would say what? Simplify. The instruction wouldn't read evaluate or find. All right. Okay. So, any questions?
For number 6, a negative level. A square b plus 10ab square minus.
Hold on. I want somebody to talk one evening. Talk. Now call upon some name. Call upon some people. We don't talk yet. Nikisha?
Sir.
Hold on.
Sir. Nobody call me if me last one more time me people them call police. Sir, nobody call call Nikisha.
You call police for me?
No, me say if me last one more time me people them go call police. So no call me. No sir. No.
You lost, me understand.
Yes, sir.
Because they go on.
Just give somebody who is willing to try. Just somebody
you lost.
who want to try.
Sir, for the confusion and for the class not to keep up, Kristen is going to answer the question. Right? I have a negative.
Hold on.
So yes, you know, attention, John, the class.
Hold on. So basically, it's the queen of the maths. All right, go on, queen.
No, sir, I'm not the queen of the person. The answer for the night of the queen, so you realize I'm silent. But too much confusion, so I'm going to answer if you right.
Let me say, share the bigger queen and little queen.
And where you want to put it, sir?
All right, go ahead.
Back.
Go ahead.
All right, sir. So I have...
really sure.
As an instructor, I can't go around telling people that. They're going to be confused. So it's best if I say it another way.
Okay.
No, but in fact, you know, if I write A, what is the value of A? You can't say it's 1. No, you can't say it's 1. The coefficient of A is 1. The only time you can determine what value of the letter is when it tells you what the value is. All right?
Okay, get what you're saying.
Let me tell you. A long time I teach and a long time I hear fitness and something. I don't know how. I'm wondering if it come from primary school. Students say X are 1. X is 1. No go so. X is not 1. So if X are 1, what is Y? 2?
2.
What is Z? What is Z? 3. No, don't go so.
The same.
I would say if I was inventing some foolishness, I would say A are 1 and B are 2. Not true. Why start at X? The reason why we have X and Y's and Z's in math is because of white colonialist men who invented math. They chose those letters. That's why X and Y and Z are so popular. But to be truthful, X don't have a value, Y don't have a value, Z don't have a value unless you put a value to it or the examiner state what the values are. But x by itself, ladies and gentlemen, all right? All I know that there's a 1 beside it, imaginary 1. There's an imaginary 1 to the power, and there's an imaginary 1 down here. So all those are imaginary numbers. All right? So there's no value beside it. Well, it don't have a value. It's just that it has a coefficient.
So, sir, if you have x plus 3, what you do, sir? You put over the x over the side and you left the 3 alone?
Hold on.
And you put back the...
Let me erase all of this. Okay, so you're asking me, I soon come to the question here, miss. This one show me off.
X.
Yeah, you have x plus
3. And I have equal sign, so you go carry over something.
Oh, well, we don't reach that part. That's an equation, but you have to have something over here. You have to have something over there. But if you have something like that by itself, you can't work this out, because this is a variable and this is a what? A constant. These are two unlike what? Terms, not true. But if you're talking about the equation, but if you're going to solve an equation, you have to have like a number over here. So, like what number plus 3 gives 7? You follow?
Yes, sir.
All right. Let me just continue the question, because... Go ahead, no, miss. You gone? Are you gone, brother?
You ready for me now? Oh.
Yeah. Why, some people probably laugh, you know.
1,000.
Alright, continue.
Alright, so first we're going to group like terms. So you're going to have negative 10a squared b plus, minus a squared b plus 7ab squared plus 3ab squared minus a squared b squared.
Good.
And now we group that now, so we just start to do a little subtraction. So negative a squared b minus a squared b is going to give you negative a squared b, 11. And then we're going to have 10ab squared. And being that a squared b squared don't have nobody partner with him, I stand by himself, so just put him back with inside.
Right, very good. Any questions?
Sir.
Yes.
So you could put like negative 1a squared b squared.
Yeah, you could do that. Yeah, you could do that. Because once you don't see a number beside it, it means a 1 beside it. But it's up to you to write it or not. But I can tell you that examiners, they're not going to write it. If you're going to exam, they're not going to put the 1 beside it.
Sir, I have a question. So rather than having the negative 11ab a squared b
right?
First, yeah, if I have 10ab squared take away by our negative 11ab squared.
Still be correct.
Still be correct? Okay.
Because in math, yeah, something
I did it 2 ways.
Right. So what she's saying, what if this over there, so, or this over there, so, or anyway, it doesn't matter. And the reason it doesn't matter is because of a law in math called the associative law of math. All right. We're going to talk about that some other time. All right, guys. So, any questions? All right.
Sir, could you jump out for a bit? Mama, just write this off, please.
Okay, go ahead.
Sir, that end part is what? Minus 1a square?
B square, right.
minus 1. How the 1 then?
Well, the thing about it, there was no 1 up here, so. But he was asking me if you can put a 1 there. I said yes.
So you could just leave it as it is,
Right, you could just
sir.
leave it, yeah.
A square, B square,
Yeah.
you could leave it like that?
Yes, you can.
Okay.
Yeah, because it confused me. Let me see the 1.
But just get used to it, here. Go ahead.
Alright, so where the
Can
arrow
leave
is
it, you know.
pointing, you have negative 10a squared b minus 1a, that's correct? 1a squared b.
Yeah, yeah.
Alright. I don't know how you get that.
No, I'm grouping this. But
okay, so you just
I
put
put
the
a 1
And
there.
the minus
I just put the 1 there.
them together.
Understood, sir.
Alright. Are you finished now?
Yes, sir.
Alright. So that was adding and subtracting. Now we're going to look at multiplying and dividing in algebra. So head up for me. Multiplying and dividing in algebra. Well, some of the things that we should know about multiplying and dividing is that both of them obey the same rules. All right. So both use the same rules. Which rules I'm talking about? The rules of multiplication, not true? Okay, somebody's saying that they don't get the answer for number 6. Sunita, what you don't understand quickly? Sunita, are you there? All right, somebody just texted me in the chat that they don't understand number 6. I'm not getting a response.
I just explain back over the first part, like for kind of maybe tricky fine, like the 10 and the 1 or something. Just explaining. If anybody don't understand, they can just get it and move on.
All right. So as you can see, we have a square b and we have what? AB square. Would you agree with me that those are two different terms?
Yes, sir.
Yeah. So a square b, AB square, them different. Follow? What are the rules about adding and subtracting? We can only add. The rule says. What the rule say? We can what? Only what?
Add the like term then.
Like
which
terms, right?
Are the same.
Right.
Subtract.
So, because we can't work out them two here, we can't work out them two there, but we can work out what? These two, so I group them.
Same group.
So I put them together like this. Do you see that? Put them together. Sunita?
Yes, sir.
Yeah, man. This is why I put these together right here.
Yes, sir.
This is a square b, and this is what? A square b. I just jump into 1 to help out you guys. And then now you have AB square, and you have what? AB square. So put them together like this. And then this is like a lone ranger.
You carry the signs.
Right, thank you very much. Anything in front of it, the sign goes with it, right? And you just continue, you just work out individually and you get the last part. All right?
Yes, sir. Me understand now.
All right. Let me tell you something. You see these maths, you have to write them out and practice them here. Because you're not going to remember them. And the rules are very close. All right, so multiplying and dividing algebra both use the same rules, all right? And we're talking about the rules of multiplication. For example, negative and positive give you a negative. Positive times negative give you a negative, that kind of rules, right? So we know that from start. The second point is that we can multiply unlike terms. So that, yeah man. For example, A times B. What's A times B?
AB.
AB. But can I say A plus B?
No.
Because A plus B, they're unlike. And you can't add unlike, but you can what? Multiply unlike terms. What's A times B times C? ABC. Right. We notice all those terms are different and true. So we can multiply. All right. So that's point number 2. We can multiply unlike terms. Any questions? Anybody lost? All right. Point number 3. When we multiply with same base, we add the index by handwriting skills and quad. I could compete with any grade 3 Pitney. All right. When we multiply with the same base, what am I talking about? For example, if I have A to the M, you see this here? It's called the base. And the power is called what? Index.
Index.
Right. So what this is saying that if you multiply with the same base, for example, m to the 3 multiplied by m to the 4, what am I doing? The m and the m are same what? Same base. True. So what the rule said?
Keep the base at the index.
When you multiply with the same base, add the what? Index. So you add 3 plus 4. So you get m equal m to the 7. And why is that? So when we multiply with the same base, we add the index. All right, what happens when we divide with the same base? What do you think is going to happen?
We take away.
Right, thank you very much. So the last point is that when we divide the same base we subtract the index. Example, if I have 5 to the 4 divided by 5 to the 1, I'll get 5 to the 4, subtract 1, which is 5 to the 3. Alright, because it's 5, you can actually work out a value. 5 to the 3 is actually 5 times 5 times 5. What's 5 times 5 times 5? 125. But if I use a letter like M, you have to leave it like that. Alright? But essentially, what I'm trying to say is that when you divide them the same base, what you do? You subtract. When you multiply, what you do? You add the index.
Me just want me not figure out something. How you get the 12? What you have down at the bottom? 125, 125, or you just have I don't know. When I get down there, so you can just go over from the. I understand that when you divide, you take away.
Alright, so we have 5 times 5 times 5.
5 into 5 is 1.
I have 5 times 5. I have 5 to the 3, right? 5 to the 3 means 5 times 5 times 5. So 5 is 25, and 25 times 5 gives you 125. You actually get a value because those are numbers. But if you notice M, the other example with M, you have to just write back M.
So what I want to know, is it that after you do the 5 divided by 5 and you take away 1 from the 4, I just kind of work it out to get you. Take away 1 from the 4, leave 3, that would leave equal to 5 square. So then you would put equal 5 times 5 times 5 equal to, then you get the answer for 125.
Yes. Come on.
5 is 25. 25 times 5, 125. Okay.
That is 5 cube. You multiply them all.
All right. Any questions? Anybody writing? All right. Let's look at some examples. An instruction would say simplify. So you won't see solve or anything like that. Oh, by the way, make a note of this. Any number raised to the 0th power is 1. Alright, so 5 to the 0 is 1. 1/3 to the 0th power is 1. Alright guys, any number raised to the 0th power is equal to 1.
Okay, so we must write any number raised to the 0th power.
0th power is equal to 1.
is one example. Okay.
Let's leave a little space. Oops. Oh my. What did I do a while ago?
You racing.
Oh.
So I'm finished. Sir, you had negative 4x.
Oh my, I found it back.
Third
Thanks.
power.
I found it back.
Okay.
All right, so to answer this question, there's a little rule. S and L. Work out the sign first, number then the letter. So a negative times a positive gives us a what? A negative, agree? 4 sevens.
Yes, sir.
28.
28.
All right. Now you see,
X7.
all right, you see your answer? The answer, all right, how much x we have up here, so? We have 2x. But your answer going to have what? 1.
1x.
We have 2y, you're going to have what? 1.
1y.
And then we have 1z, we're going to have 1z. All right? So that's what you need to remember. So you're going to have x times x times x times x, 1 million x. When you work it out, how much x you're going to have? 1. And then you put the number up there, so not true. All right?
Yes, sir.
All right, so what we're going to do next is well, the rule says when you multiply the same base, you add the index. So the x3, you're going to work it out with the what? The x4. So 3 plus 4. So 3 plus 4 give us what? 7. And then for the y, you're going to have y
2
square,
plus,
right? Plus 3.
Plus y3.
That's y to the what?
5.
And because you only have 1z, you just write it back. So this would have been our answer.
Go over that again, sir. It's a bit confusing.
All right, so what did you work on? The sign first, the number, then the letter. So negative times positive gives you a what? A negative. So negative and positive give you a negative. Then work on the number. 4 sevens, 28. Then no, you only can work x with x. So the x3 and the x4 can only go together. So when you multiply with the same base, you add the index. So 3 plus 4 gives you 3 plus 4 gives you 7. And then you look at the y's, and you add 2 plus 3 to give you 5.
Okay.
I mean, these questions, they can be mentally. You don't have to go through all the rigors I do, but as you can see, even when I go through it thoroughly, person still find it confusing. I said, well, sir, we can just do the easy way. I can, but you have to remember that we have different learners in the class, all right? And different learners at different stages of their development in math also. All right, for this one, what I'm going to do, I'm just going to bracket those two. All right, so negative and negative give positive. 3 2s is what? 6? Following?
Yes.
And then now you group the A. You look at A, this A, and look at that A, and you say, no, something, only one A I'm going to have. And that's a B, and then another B, right back one B, and right back a C. As a matter of fact, C doesn't match with anything over here, so you just write back C4. All right? But A, what you know? A3, now what power is up here, so? An imaginary
One.
what? 1. So 3 plus 1 will give us what? 4. Likewise, the B, 1 plus 2 will give us 3. You guys following? Any questions?
Can I get it?
So
Maybe
for that,
I can go back one more time, sir?
But you say I get it.
Sir,
You say
so
I get
for
it,
that, no, because the
Just
variable
repeat
different.
again.
No, you have to group them like that. Bracket.
Let me tell you, you can actually get a one shot. You can get a one shot at it, but I like it step by step. You follow?
Okay.
All right. Okay, I said, boy, sir, we can't buy that, you know. There's no fast things, you know. But the thing about it, learn the principle, all right? When you learn the principle, you can do the fast thing. Because you're doing an exam, you panic, you start to fret, everything flat ahead. But the principles don't flat ahead, don't you? When you were raised by your parents and you go to the world of work, right? The principles is what you remember most about growing up, don't you? The good principles, right? And as a matter of fact, those are the principles that we live by. So, all right, so then now we're going to work on another piece. So times 10 b squared c. So 6 times is what? 60. We have a4, where there's no a over here, so right by the a4.
60.
And then we have
6
B,
times 60.
right? 6 times 10 is 60. And then B3 and then B2 give what? B5. See that? C4,
Yes,
C4 and C1 will give you what? C5.
C4 and C4?
Sorry, C4 and C1.
Oh.
See, I probably said the wrong thing. C4 and C1 will give you C5.
Okay.
So the answer is 60, A4, B5, C5.
So, sir, so when you have a single letter, like how you have the C standing alone, you would use a 1.
Yeah, there's an imaginary 1 there.
Okay, so whenever you have a letter by itself, there's an imaginary 1. So I must always remember that, right?
Right, as the power.
Okay.
Just like we have a coefficient of 1 beside it, you have an imaginary 1 power.
Because when you wrote the wrote it down before, I didn't really see that at first it appears that it was BC together. I didn't really see that the B was by itself. But when you started to working it out and I saw that you put the 1 there and add it to the 3, then I realized that the B must have been by itself for you to put the 1 there.
Yeah, you're correct. All right. Okay, so let me give you a minute. Anybody, you guys are finished?
No, sir.
All right, let me give you a minute or two to write this up.
Sir, class over. Sir.
Yes. No, man. Why is that?
Back hurt me. What time class are over?
9:45.
Huh?
9:45.
Okay.
So you're not sitting?
Yes.
It's probably sure. Or probably sitting back.
Yeah, probably. Go just stretch.
All right. So can I move on, guys?
No, sir.
Wait,
So I'm just,
All right.
I went out, I just came back.
Okay. All right. So what we're going to look at next, while you're writing, is that we're going to look at how to divide. Which is pretty straightforward.
Finish.
All right. All right, so I'm going to move on. So more examples.
So me can see last record, please.
We can't.
I'm gonna get kicked out.
Ready now?
Yes, sir. Thanks.
All right. Okay, so while I was okay, look at the question. Okay, yeah, you guys have that? So to work this out, you know, when we're dividing fractions, right? We always change division sign to what?
Multiplication.
Multiplication sign.
Right.
And reciprocate to one of the fraction.
Guys don't notice how places get cold all of a sudden.
Huh?
So you'd flip it, the 28
right.
MN would
You're
be
gonna
at the
flip it.
top.
No, I was just saying that you guys notice how the places get cold all
Very
of a
much
sudden.
so, sir.
I don't know what's believe it be yet. We have to worry
Alright,
up.
very, especially in the mornings. Trust me. Alright.
Well, the fog is on your thick until around 10:30, then 10.
Where is that?
Cambridge.
Okay. Alright, so then we're gonna cancel, aren't you?
Yes, sir.
So we know that the 5.
1. 5 into 5, 1.
Right. And 25, aren't
5
you?
times. Yeah.
Then we can use
14, 1. 2
14
times.
equals 2.
2 times.
Alright. Alright, so
Then you multiply across, I think.
alright.
So you'd have to break down the A.
Right, the A, right. But the space, not try to figure out right now.
So just cancel
All
out
right.
your.
So I'm gonna say 5 2 is 10. All right. So and then what I'm just gonna write all these letters here. Write them back. So you have A 3,
B6,
B6,
M
and what? 5, aren't you?
5.
All over. Well, 1 times 1 is just 1. We have M and 3. We have A B3. Everybody see that?
Yes, sir.
All right, so then we're going to cancel. So clearly, the M cancel, not true? So
yes.
we have 10. So watch now. Watch carefully now. You guys looking? Nobody will tell me don't listen, no understand. Please look.
Yes.
All right, look. So we have A and A. We have A1 and we have A3. Those are the same what? Base. when you have the same base, what do we do with the index?
Add them.
Subtract. No, man, we subtract.
Subtract, sorry.
So 1 take away 3, I'm going to give you 2.
A2.
That's A2. Everybody see that?
Yes, sir.
Look at the B now. We have B3, we have B6. When you divide it with the same base, we subtract. So 3 from 6.
B3.
Let's give you B3.
3.
Alright? Let's go to the N now. N3, N5.
N2.
N2.
Sir, you said you were going to talk about the SBA before you close class.
No, man, I said next week we're going to do everything. We said next class I'm going to get a master list from the principal, and then we're going to do the actual grouping. Well, you guys don't tell me who your group members we have selected, and the ones left back are just randomly selected persons. All right. So the thing about it, not everybody's on class live. So you might find out boy internet gone and next thing in a group. But I have to group you guys, right? So what I'm gonna do next week is to see if I can group you, have the names down, and assign topics to you, discuss the topic. All right?
Sir, so you're the one that is going to assign the topics to us?
Not necessarily. You can deliberate on a topic.
Sir.
Yes.
I'm sorry. It's about the question that you did on the board. The 28 and the 14. The 28, is that a 2 above it?
Yeah, because 14 goes 1. 14 to 28 goes 2.
Okay.
So remember, SBAs must be authentic, meaning that you have to carry it out. I will tell you a story about a student who mashed up our entire group because he decided that he didn't want to know SBA because he had one emerging game from high school, and not everybody in the group wanted to do that because they felt embarrassed. Because what happened, when everybody go to do an experiment and a survey, and say, give me a feedback. And everybody start to discuss and then say, give me a feedback, nobody can answer nothing. And then all of a sudden the person stopped come class and peer problem. So if you have an old SBA that you want to use, you may use it, but please carry the experiment. Don't use that same SBA. Because as you know, SBAs are, what CX is going to do is that they're going to mark them individually now. What happened in the past is that they only took a sample from the entire class. They only probably mark 5 out of the entire class, but now they're going to mark every single one of them. All right, and all right. So let me give you 2 to try.
Homework that, sir?
A
homework?
You want homework?
Yes. We can get that for homework. We can practice that, please.
Well, you're gonna... No more, we have to try this now. So the instruction says to... We soon finish one. Simplify. You guys are not tired like I am, trust me. All right. All right, try those two. I'm gonna give you 4 minutes for those two, all right? I'm gonna step away from the computer a little bit, all right? So if you talk to me and I don't respond, it's because I step away.
Sir, that's a positive 40 x squared y 4z.
Go first.
You're gonna
You're gonna work out two, not true?
yes.
Yeah.
Multiply.
Then negative 5 times 2 is what? Negative 10. We have x, that's 1 and that's 1. That will give you what?
10.
2. We have 1y and 1z, so just write it back. See that? Everybody following? Then 2 negative,
Yes,
we are
sir.
positive. That's 40. Right by the x, right by the y, right by the z. x2 alone, so you just write back x2. y3, y1, y4, and only 1z. Or what some people do is just look at it and say, boy, blah, 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 and just boom, bam, and work it out.
Okay, sir. Get where I say now.
Yeah. All right. The last one, by the way, this last one will take us out. What I would do is, can I erase number 1? Hold on, let me see this thing recording. Okay. All right, guys, remember, before I even finish, remember, whenever you're watching the YouTube, sit down with your book and with your pencil and go through it step by step, right? Don't just bother look upon it and glimpse it, and especially the last one. The last one is almost 2 hours. And if you notice, I had some of my high school kids in the last part, some more practice questions are there. All right. Okay, so for this one, what I'm going to do, okay, what you could do is all right, let me show you something. Another way of doing all of this is you could actually write the whole thing. I'm confused, but this is another approach. For example, the top piece here would be 3. A3 would be what? A times A times A. You guys following?
Yes, sir.
Yes.
Times C times 3 times A times what? C times C. CXC. Then we have 6 times A times C times C times C. Boy, I must CX, you know, do. Watch it. Watch it now. So, let's look at the numbers. So, this 3 and that 6 give a 2, don't you?
Yes, sir.
Alright, so watch it now. We have 3C down here, so. And we have 3C, so all I see them cancel out. We have 1A down here, so. And that 1A cancel out, that 1A. Alright, so what left back is 3.
3 over 2.
Watch out, we have 1, 2, 3. So it's just 3A cube.
Sir.
Let me get to some of that one.
Sir.
Right.
Sir.
Go ahead.
I got the 3 over 2, but I had A5 and C2.
No, that's wrong. Because as you can see, all the C's cancel out.
Yes, yes. When
Alright,
I look
guys.
at it, yeah.
Alright, do you have any more questions?
No, sir.
Okay, so we're gonna end class. Easy. Keep safe, travel safe, and take care of yourself, alright?